Logarithms or logs for short aren't that easy to understand if you have ever tried understanding them. The general bookish definition of logarithms is it is inverse of exponentiation. So if you want to say 3 times 2 is 8 in exponent, then you can say the same and in the inverse is log 8 base 2 is equal to 3. Simple way of saying how many 2's you'll have to multiply to get 8. That's the log for you. Cool, right? You might have also seen this very famous logarithmic graph and applied the log formulas or properties n number of times in your maths, physics and chemistry problems. But where did this actually come from? Way back in 1700s, before calculators were a thing, people used to do operations manually. Arithmetic operations. And doing simple calculations on large number used to take days. Logarithms are like ciphers in cryptography. If you encode something using an algorithm, you can easily decode that if you know the algorithm applied. Logs or any functions are very similar to this. Logarithms were introduced to represent larger values on smaller scale. The table being the algorithm or the encoding-decoding rulebook. So let's take an example. If you want to perform the multiplication operation on very large numbers, of course 2 large numbers, take the log of both the numbers and add them. This will simplify our calculation. Let's now see the application of logarithms in our day-to-day life. Richter scale. It is used to measure the intensity of earthquakes. It is a base 10 logarithmic scale. So let's take an example. An earthquake of magnitude 5.4 and an earthquake of magnitude 6.4 are just 1 unit apart. The difference increases in multiples of tens. See you in the next one.